So, welcome to everybody who joined in. This is, as my understanding, maybe the first Tech Lancaster kind of streaming online like this. So it's a new experience. Hopefully, everybody enjoys it. Um, Before I get started, uh, I have some announcements to make. So first, for April, the AES team will be presenting our approach to introductory computer science for middle school students. We will be sharing our experiences building practice exercises using the open source Blockly Foundation. If need be, this will be streaming only. Also, Lancaster AI is scheduled for a remote meetup on March 31st. The talk will be on building AI agents in Unity 3D and their AI simulation software. Should be great for game devs, robotics, and AI folks. Streaming details to be provided via the lancasterai.com website, as well as posted on the Lancaster Tech Slack channels. Also, April's Lancaster front-end meetup is canceled. Look for more details in their Slack channel or on their meetup.com page. And finally, the March Lancaster LUG meetup is canceled. Okay, so with the announcements out of the way, I just wanted to thank everybody for coming out tonight. So just for the introduction to F# talk, just a little bit about myself. My name is Jeff Beitzel. I'm a software engineer. Throughout my career, I've worked on a myriad of different languages and technologies, but in my spare time, I like to play around with tech as well. So I've played a little bit with Scheme and with Racket and Haskell, but right now my real passion for hobby projects is actually F#. So what I wanted to do is share a little bit tonight about the language F#. So before I get there we go. So also before I get started, my original intent, because this was going to be in person, I was hoping for it to be pretty interactive. I just to try and get a feel for where people are and what kind of things they're interested in. Through the stream, it'll be probably a little bit more complicated, but post questions in the YouTube Slack in the YouTube channel, and I will try to answer them as best I can. I'm also available through the normal Slack channels if we need to do anything offline. But first, so as far as the agenda for how I was going to approach this tonight, first I want to tell you a little bit about what F# is, kind of where it came from and what it tries to solve. Then I'm going to show some code examples. I feel a good way to kind of understand a language is to see how it solves its problems. And then finally, I want to finish up with the what the F# ecosystem looks like itself. So first, what is F#? It's a language that's in the ML family of languages, and that's not machine learning, but meta language. If you're familiar with languages like OCaml, they are very similar, and this will be very familiar to you. Other functional languages that will probably look very familiar to you as I go through the talk tonight are Haskell, Scala, Elm, OCaml, obviously. So you'll certainly see some correlations, correlations between those, and hopefully that familiarity will help. Also, if you're a C# or a VB.NET developer at all, F# is in the .NET ecosystem. So what that means is it's a fully fledged .NET language. It has access to all the normal libraries that you have if you were writing in C#. It runs on the CLR, so all the advantages and sometimes disadvantages from the .NET build system you get with F#. So F# started in Microsoft Research approximately 10 years ago. You can kind of think about it as if you took OCaml and tried to write it into the .NET ecosystem, what would that look like? Leveraging the way that the CLR handles languages. Also, F# is a general purpose language. What that means is it's not specifically meant for machine learning. It's not specifically meant for reporting. You can write anything from web servers and web pages to mobile applications and backend processes and scripting. So it serves the gambit. Also, it's multi-paradigm but functional first. And what that means is, as a functional language, the preferred and kind of best practices within the language are functional approaches to problems, but it also fully supports object-oriented methods as well. So what's really nice about that is it allows you to kind of get the best paradigm for the particular problem you're trying to solve. It's also nice, and actually it's almost required in some sense when dealing with the .NET library system, because a lot of that is class-based, and so you deal with a lot of object-oriented stuff in F# as well. So when I say a functional language, what exactly do I mean by that? Many functional languages have similar types of attributes, and one of the ones that you hear most often is actually immutability. And so what that means is, as a variable is defined, when it's defined, it gets a value, and that value doesn't change. And one of the benefits of immutability is that one of the advantages of immutability is that when you don't have to worry about data changing underneath you, and that also provides some nice ways to facilitate solving problems. Also, functions are first class. What that means is functions can be passed into other functions as parameters. They can also be returned from functions as return results. Also, F# has a rich type system, and I'm going to go into that a little bit later in the talk, and that ties directly into the type inference. There's a lot of power that the F# type system brings to the table. So, kind of, after I given a brief introduction here to F#, why should you care? And this is perhaps heavily biased from my perspective, but the language assists the developer, and I would rather expend my effort solving the business problems than not fighting with the language and fighting with the tooling. And the language syntax and the language tools and libraries it brings to the table allows me to do my job better and lessen my mental load. One of the ways that it lessens that load is it removes whole classes of errors. Kind of the canonical example I jump to is that F# by default doesn't have nulls. Now, that is a little bit of a lie, because when you're in the .NET ecosystem, and especially dealing with external libraries, it does have to be able to support nulls, and it does. But if you're writing an application that is kind of purely F# and not calling out to a lot of external things, nulls are something you don't deal with, and you don't have any of the problems that go with nulls. There's also some very specific syntactic tools and keywords like match that assist the developer. They give you compile time errors, so it makes it a lot harder to have a problem. Also, it's a pragmatic language. This goes a little bit to the fact that it's multi-paradigm. It allows a lot of flexibility on my part on how I want to solve a problem. Also, as being a part of the .NET ecosystem, I get the full power that comes with that, and from my perspective, that can really help me solve problems. Also, regarding the type system, it encourages domain modeling, and that can mean different things to different people, but for me it encourages the developer to take the business rules and take the business logic and actually encode it into the applications itself. And what that brings to the table is a lot more focus when you're designing. It makes you think up front a lot more, which means some of your work later is easier. Also, you're giving information to the compiler when you do that, and that means the compiler can throw warnings and throw errors when you're making mistakes, and that again goes back to assisting the developer. Also, it simplifies refactoring. For anybody who has had to refactor code they're not familiar with or code they wrote that is from 6 months ago, refactoring can kind of be a nightmare, and you kind of pray that your unit tests catch the any problems that might occur. But what's nice about F# is the language itself assists in refactoring, and it makes it a lot easier, and it can tell you what kind of things you have to change and where you have to change them. So moving on to the second part of the second part of the talk is looking at a little bit of code. And so this is where one of the places I want to try and find a little bit of balance, because I feel that one of the good ways to get a feel for the language is to look at how it solves problems, look at its syntax, and understand how it flows. But I also don't necessarily want to read a bunch of coding screen. I don't want to read a bunch of code out here, because I don't think anybody wants to listen to me recite code that they can read themselves for the next 45 minutes. So, but as an example program, it's actually a pretty simple example. What it does is it takes a file. When you run the program, it takes a file as its first argument. It will read that file in. It will count the non-blank numbers, and it'll determine whether that count is even or not, and just kind of do a simple printf at the end. So a couple things I want to call out here, and as you're looking at it, one of the first things that might stick out to you is that there are no curly braces. F# is a language that scope is defined by indentation, and so and that's very similar to other languages such as Python or Haskell. So I know sometimes that this can fall into the religious set of whether that's good or bad, but I've actually found it to be nice. It takes a lot of that stuff that I skip over mentally in my head, and it just removes it. I mean, I spend most of my time indenting. Not most of my time. I spend time indenting my code anyway, so why not use that to my advantage? Also, so on lines 3 and line 6, those are functions, and you'll notice there's no parentheses, there's no type definitions, and that's where type inference comes into play. Also, on lines 8 and 9, you'll notice a bar with a greater than sign, and that's called a pipe in F#. And you will see that a lot in F# applications, and what it does is it takes the results from one function and passes it in as a parameter to a following function. So in the case of lines 7 and 8, it will read all the lines in from a file, which that function actually returns an array of strings, and it will pass that array of strings into the array.filter function, which as its second parameter. Its first parameter is a function. It's just an anonymous lambda, and then that allows you to actually filter an array. Let's see, is there anything else? I don't think so. I know that we work on a little bit of a delay, but certainly if you have any questions, just put them in the channel, and I'll try to answer them. So, also, I guess to get a little bit, when I look at the code here, I'm not going to walk through all the syntax of F#. That would take way too long and probably bore people. So what I want to do is I want to give a couple examples here of the common types of things you do in F#, but then I also want to call out specific language design that I feel makes F# interesting and powerful. So as far as common usage, the first one is variables. So we have a couple examples here where we can define an integer for 10. We can define an object on random. Love coffee is also a tuple. That's a language construct that's built in by default for F#. For people who aren't familiar with tuples, they are a way to aggregate different pieces of different values kind of together without fully fleshing out a class or a record or some special type. It's very lightweight and can be very useful. Now, also, originally I had said that F# is immutable, and it is, at least immutable by default. But inevitably there are times when data needs to be changed, and there is a method for that. But you have to explicitly specify that the variable is going to be mutable, and you have to use the left-hand arrow on line 9 to set that value. And what's useful about this is that whether you're doing code reviews or of unfamiliar code or yourself, it's a nice way for it indicates code smell of, well, is this the proper way to do it if they're using mutable variables. Or if it is the proper way, it at least helps your mind to be in tune that something special is going to happen here and you should watch for it. And this goes back to why I think immutability is so powerful. There are a lot of things I don't need to worry about. But when I do need to worry about immutability, it's called out explicitly in the syntax of the language. Going a little bit deeper into variables and the fact that F# doesn't have nulls, there's something called an option type. And what that is it's a very specific construct where a variable can have a value, none, or have a value, in case of the line 9, you explicitly call a sum on it. And this also forces a developer to figure out, can I have a variable that actually doesn't have any data in it? And I don't have to worry about nulls randomly popping up. It's specifically written into my business logic. It's written into my code that I want to handle a value or I don't want to handle a value. It is similar to nullables in C#, but from my time in C#, there are some limitations to the way nullables can work and what they'll let you put it on. But option types you can use against anything, and you can extract to see whether it's isSum, like on line 4, or the match keyword. And I'm going to go into match a little bit later, but you can think of match as a switch statement on steroids. It effectively does the same thing and a lot more. So in this particular case, if 50 has if the variable 5050 has a value in it, it'll extract that value and print it. And if it doesn't have a value, it'll print something else. But this is kind of the way that you would use options. You'd set them with using sums and a number or none, and then you'd extract them typically with a match, but there are other ways to pull that data out as well. So what do functions look like? So I have a couple examples here. The first example is a case of where I actually explicitly define the data types. It takes in 3 variables. It takes in 3 parameters, 2 ints and a bool, and it will return an int. My second example is a function, but I don't define any data types. And the compiler is smart enough to know that as long as I call the function doubler with a value that works against the plus sign, this will compile. If I try and send a string into this, it won't work. So also, since functions are first class, on line 6, I actually have a make_adder function where, given a value, it will return a function that adds that value to the number you give. So you'll see in line 8, I'm actually building another function that I will add 20 to it. So on the last 3 lines of this slide, on 10 through 12, this is how functions are called, and you don't use parentheses. It's actually all space delimited between the functions and the parameter names. Also, collections are a big part of F#. So there are other things such as hash maps and sets, but just to focus here on lists, arrays, and sequences. And you can think, for what it's worth, sequences are, you can think of them as lazily evaluated lists or enumerables. One thing that's nice about these collections is they all share similar function sets. Like, you'll notice that list and array and sequence all have a map function. They also all have filter functions and reduce and folds and group bys. And from a discoverability standpoint, it's nice. If I'm working with a list or if I work with an array, it effectively works the same way. I mean, under the covers it's different, but from a coding perspective, they're very similar. All 3 of these examples have ranges defined. You actually define a list with just the square brackets. So on line 2, you define arrays with the square bracket and the pipe, which is on line 7. Also, line 7 is a range with a step on it. And what I've also done is put comments underneath of what the results would look like. And on the third example for the sequence, so sequences are a little bit more complicated, but when you're doing lazy evaluation of values, you can use yields and ranges to build special kinds of constructs. And let's see. And again, we see the pipe operator, so we'll take a range, pipe it in we'll take a range, pipe it into like the list.map. It will apply that function to every value there and return a new list. But as you may also notice in the second example, you don't have to use the same data type. Map can actually map to different data types. So in the second example, it's actually mapping an array of ints to an array of strings. This is also just another example of how you could potentially use lists and the pipes together. Pipelines are a really powerful way to transform and manipulate your data. I kind of just wanted to call out a couple different ways that you could work with this. So you can use filters to limit your data, in this case to just even numbers. You can then apply the doubler function from earlier, where it's just going to take any value and double it. And then there's a concept called a group by, and what that does is it will actually take your anonymous function and however that maps against your data, it will actually create keys with associated lists with it. So it's a nice way to take a big list of data and group it into a specific groups, and then you can sometimes you do sums or averages on those. In this particular case, I'm just going to iterate and print it out. Now, because group by returns tuples, I can use the first and the second to extract that, and that's what you see at the bottom of the slide. So continuing on some of these code examples, I stepping kind of calling back to earlier with some of the domain modeling and the types. I thought it would be good to use some example that I could pull where types matter, and so I thought it would be kind of fun, since we're in Lancaster, or at least virtually at this point, and I enjoy roasting my own coffee. I thought it would be kind of fun that if I was to create my own coffee shop, my own coffee roaster, I would need some software to run it. So the examples here kind of play off the idea that there's a Sharp Roaster's coffee roaster, and we need some code to actually do some work. So if we look at types, types actually provide a lot of power in the domain modeling for F#. They can be as simple as effectively an alias against another type, like a coffee ID to int. That can give you some value when you're using functions, so you don't accidentally send in a batch ID or an order ID instead of a coffee ID. It allows some very simple checks to kind of save the developer from some stupid mistakes. Also, there's a concept called a discriminated union, which is what you see for the remainder of the types here on this slide. And at least for the first example on line 3, you can kind of think about it as an enum type, but it's the discriminated union is more powerful than that. If you look at the second example, coffee can when they're extracting the coffee beans from the coffee fruit, there are a couple different ways that they can get that out. And so sometimes it's dry process, where it effectively is heated under the sun, and sometimes it's wet process where they run it through special machines. Sometimes there's some sort of combination of both, and so at least in this example, I wanted to provide a method of, well, I'm going to use a string to describe the way that processing method was. It's kind of a catch-all way for me to handle lots of different situations. But taking it a step further, maybe when I build my website, I want to have some searching criteria either against different coffees or stores or suppliers. And there's different ways that I can search against that data. And so maybe I want to search based off of rating, which could be an integer, or the description, or maybe the processing method. And what's great about discriminated unions is it allows me to encapsulate different types of data into the same construct and provide signaling about what that data is, and I get all the type safety and compilation benefits from that. So another type construct in F# that provides a lot of power are what are called records. And this will actually be one of the, well, I guess you saw it on the sequence, but this is one of the first places you really see curly braces being used. So records, you can kind of think of them as a very lightweight class with attributes. And so what I have here is two examples. So coffee beans have their own sort of taste profile, and I've abbreviated this list here where it's just complexity in body and fragrance, and they're all floats, but it's a way that people can mark what kind of profile the coffee bean has. In the second type here on line 3, I define a specific coffee, the country that it's going to come from. Again, here on line 6, you'll see the 6 and 9, sorry, you'll see the option type. And so I'll always know what country it comes from, but I may not know what farm it comes from. And that's specifically built into my typeset. I always want to know what the process method is, and it will be of a limited set, as well as profile being a more complex type. And then finally the cost per pound. And so in this case, I just chose a decimal. So this is how the records are. This is how the record definitions look. This is actually how the records would be used. So I have two different examples here. On the first example, I know what the country is, I know the farm that it came from, and I have to explicitly define that. But in the second example, I don't know where the farm comes from. And so there, I don't have to worry about nulls again seeping into my data. I use none. I just use a none, and that's nicely coded in. So one thing that comes up is when you're dealing with functional languages, and immutability, how do you deal with modifications? And so records have a construct of effectively cloning a record, and you'll see that on 19. So I like to use the prime when I'm making small modifications to a record, and so coffee2 prime is exactly the same as coffee2, with the exception that the cost has changed. It's going to be $6.01 per pound. And what's nice about this is it's an easy way to copy data through, and then potentially that data could be used elsewhere depending on how it gets manipulated. But this is a good way for me to make changes to data without actually changing the underlying data, and it forces me to kind of step through a process. Again, for records, what's great about records is it provides a lot of definition of business logic, but that does come a little bit with a cost. I mean, it's more to define the types and keep them maintained, but new as of F#, I want to say 4.6 or 4.7 is a concept called anonymous records. You get all the type safety you get of records. When you define your anonymous record, you still can only define it, in this example, you can pull the .name and the .rating out. This is all compile time safe as far as their data types as well. But sometimes when you're doing JSON serialization, or when you're pulling one-off queries from SQL, it's cumbersome to build the explicit types out, and so it has this concept of anonymous types where I can quickly pull it out. This is a type of thing I might use in a function. I'll extract my data from it, and then it'll get thrown away, and it won't be used anywhere else in the application. So after all the discussion about records, F# does support classes, and this is an example of what a class would potentially look like in F#. So the case here is I want to build a class that I can use as kind of a controlling class for a serially connected roaster. So one thing on line 1, you'll notice the parameters that are attached with the type. F# only supports one constructor in a class, so you don't have multiple constructors, and the way that you send parameters into your attributes are through the initial type definition. Also, because I want to track whether the roaster is running or not, I actually am going to have a mutable variable here, but it's something that allows me to know that this value is going to potentially change underneath me, and I have to be careful about it. So also, when I'm defining member attributes, those are like on line 4 and 5, and you can define member functions. There's also overrides. So this is generally kind of how a class would look like. And kind of a specific call out too, I like to use double underscores, but as long as you're consistent in your class, you can use whatever you want. A lot of people like to use this, or sometimes just an X dot, but for me it helps to really call out what the member methods are. And this is how a class would be used. Now you will notice in this case that the parameters when you're creating a class aren't space delimited. It is actually a tuple of values that come in, and that's just more of a construct of the way classes work. So getting back to the match, I want to provide two different examples here of where I think some of the power of the match comes from, what match brings to the table. So the first example, I just want to take a processing method and I want to return a friendly string. Now, what's great about matches is if, for example, I don't include in line 4, let's say I don't include line 4, I only have wet and I only include custom, I'll actually get a compile time warning that tells me my method hasn't been fully handled in my code. And this goes back a little bit to the refactoring as well. If in the future I decide to add more processing methods, I can simply add them to the discriminated union, and match will tell me when I'm missing cases where I'm handling it. So I don't ever have to worry about, I've certainly run into cases with other languages where I use a switch, I change the way the enum is, and I forget to change it in one place. I don't have those problems with match. The compiler helps me refactor my code. And in the first example, I've actually handled all the cases. Now, line 6, I have a commented out line. Sometimes you just want to do a catch-all. So maybe I want to do one thing for wet and I don't really care about anything else. I can actually use a catch-all line, which is the underscore, and that will say anything else that matches this, do this instead. And underscore, and I think some other languages have this construct where it will consume the value, but you're explicitly telling the system you're not going to use that value anywhere. And I suspect that you get kind of some efficiencies from that. In the second example, the match is actually going to compare two variables simultaneously. So if I know what the country, if the country is Ethiopia and I know what the farm is, I'm going to display one value. If I know what the farm is, but it's not Ethiopia, I'm going to display a different value. And if I don't know what the farm is, well, then I'm just going to display the country. But again, this is something that exhaustively handles all of the cases that would come in through country and farm. And if anything were to change along the way, I would either have to change it here or get a compile error or compile warning. So moving on to another concept in F# that I think is really interesting is something called a mailbox processor. If you are familiar with the actor model for development, or they're kind of lightweight actors, you can also think of a mailbox processor as a lightweight thread that has an inbox queue associated with it, and you can send messages to the queue. And as the processor gets your message, it will process it and then move on. And so it's a nice way to handle asynchronous processing in the background. Now, I'm not going to go into the all the code in the top of the slide unless people want me to, but you'll see on the bottom two lines, this is how you would actually pass data into the mailbox processor. And again, this is type safe. So I can pass in a very specific coffee type and a very specific profile type, and then the processor would kind of internally handle that. But I think there's a lot of value that can come from this kind of model, and so it's a really useful tool to have when working with F#. Speaking of async, F# has an async construct for asynchronous computation. They're very similar to tasks, but there's a syntactic sugar around it, as well as it being nicely composable. So we don't have to worry too much about the top half of the slide, but I've kind of created an arbitrary construct where there's a long-running query, and so it's going to run asynchronously, and I have different types of queued and complete batches that I potentially want to run off of that. But if you look at line 12, this is how you would use async calls. Well, potentially, so you run your query and it's effectively an async await. I'm going to run the query and I'm just going to wait for it to come back. But if you look at the second example on line 15, I actually can provide async a list of different asynchronous things and then run them in parallel and then wait for the results to come back. And so this can be really nice when you're if you're doing kind of some back-end script. Well, you could use this other places too, but if you have some back-end scripts and you want to simultaneously just run a lot of similar types of computations, you can do that. These are really nice lightweight constructs. Working with other languages, sometimes you have to pull in full libraries and build a lot of kind of infrastructure around that, and this is a nice lightweight way to do some of that same thing. Also, so units of measure, I actually don't really use units of measure in my code, but I wanted to bring it up because if you really want to take domain modeling and some of that business logic to a lot deeper level, you can actually, there's a concept called a measure, and you can actually custom define measures. In this case, I've defined pound and kilogram. And if you've ever accidentally sent the wrong scaled value into a function, you can potentially appreciate this. So in here, I have two batch sizes that I've created. One is based in pounds and one is based in kilograms. Line 6, that's actually a compile error. The system understands that those tags associated with those values don't go together. And so this can be a really nice tool for some cases if you ever worry about accidentally sending feet into something that would be meters. If those kind of problems matter to you, they are actually solvable in code if you're willing to define that kind of information out. F# has another interesting concept in its ecosystem, and it's called type providers. So this isn't a default language construct, but it's facilitated by the language in that type providers are a way that you can dynamically generate type-safe and compiler-ready code. So there are different types of type providers. There's in this example, it's for a CSV, but there are other type providers for like SQL and the R language, where it allows you to interface with other libraries. So what type providers potentially bring to the table are quick prototyping of code. So as an example, if I know what my CSV will look like, and that's the example at the top, the CSV provider will at compile time interrogate that template, find the columns, the column headers. It will actually interrogate the data itself and recognize that batch ID is an int and date is actually a date. And then under the covers, it effectively dynamically generates a record. And if you thinking back a couple slides, how that would look, instead of having to manually create all of that, you actually get that on the fly. You get all the type safety, whether it's specifically strings or dates, but you also get the attribute tags. You'll see on the last line where it's smart enough to know the row.date or the row.pounds. And so type providers can be a really powerful tool. They're depending on your use case, they also have some downsides. Since this stuff is needed at compile time, if you're using a type provider that's based off of SQL, that means the database has to be available at compile time, and sometimes that's not realistic. But when type providers can be a useful tool, they can be really powerful, and they can actually streamline a lot of things along. I've actually found when I've been playing with data manipulation, it's nice to use a type provider against a CSV, and then that way I don't have to go and explicitly define things out, and it allows me to get my scripts running a lot faster. So computation expressions. So for anybody who's listening, if they are of the Haskell mindset or they enjoy monads, computation expressions potentially are your thing. So I'm not going to go through the code that's in this slide, but computation expressions are essentially monads that allow you to handle things like state or writers or readers. F# actually uses computation expressions for implementation of its async construct and for its sequence construct. Here, what the code actually does is it does state tracking, but it does state tracking in an immutable way. And so it provides some nice syntactic sugar where, let's say I want to do some batch processing, it will actually track the batches I do over time. I can actually add them up and kind of get a sum as well as all my history over time. Now, to be honest, this is a really silly example, and in the real world, this is not the way that I would put this together. But expressions can kind of be a bear, and so I wanted to give something that was relatively simple, but because I didn't want to get lost in syntax. So the other thing about computation expressions are, if this kind of thing is not your cup of tea, that's fine. Most F# developers won't write computation expressions, but they'll use them, and they'll gain the benefits of the syntactic sugar that comes with them. So I've talked about a lot of the language constructs, and something I didn't mention earlier on is that kind of just like C Sharp. It's a compiled language. You write your code, you run it through the compiler, you get the binary out, and then you run it. But F Sharp also supports a REPL, and along with the REPL, it also supports the ability to provide scripting. And so what I've done here is, I've done my fair share of shell scripting, and sometimes working in shell or bash can be kind of a pain. There are constructs that I really wish I had. But what's nice about F Sharp is you can actually use it as just a scripting tool. So in this example, I kind of have a specialized library that I use to encapsulate the process object in .NET, and I just want to be able to tar some directories together. And so this allows me to build a list of directories I want to process. I run them against a list map that will execute a tar command that I built on the fly. And so this is a lot more work to do in something like bash. And so this is I actually find this kind of method a lot nicer when I'm building little utility scripts. So now that I've kind of walked through the syntax, I hope you have a better feel for what F Sharp looks like, how F Sharp tackles some problems. Hopefully it's been something that has kind of piqued your interest. But there's more to a language than just its syntax, and that's its ecosystem. And what does that look like for F Sharp? So first of all, it is cross-platform. It runs on Windows and Mac and Linux. When I learned F Sharp originally, I was actually on a Windows machine. I'm actually on Linux now, so it works pretty well across both. Also, it runs in using .NET Core. You can also use it running the .NET Framework or in Mono. And in fact, prior to .NET Core, you would use Mono to run it on things like Linux and Macs. Also, package managers. So F Sharp by default, you can certainly use the NuGet package manager just like you would use in a typical C Sharp project. But there has also been a F Sharp community driven project called Packet, and it's a better package manager than NuGet. It provides some nice functionality that NuGet doesn't provide. And so if you go to look at a lot of the F Sharp projects that are out there, you'll actually see Packet being used. It's also a good example of what the community can build. F Sharp is a relatively small community, but the people in there have developed some really nice things. It's a really smart and good community to work with. Also, how do you write your code? So I typically use VS Code plus Ionide. Ionide is, again, it's a community-driven project. It's a VS Code extension for F Sharp, and it provides more than just syntax checking. You get a lot of the autocomplete and a lot of the other intelligence that you would expect out of a development tool. There are a lot of people in the community that use the JetBrains writer. I've heard very good things about it, but I can't speak personally to it. I'm also a Vim person at heart, so Ionide actually does have a Vim plugin as well, and so it's not quite as fully featured as the VS Code one. So when I'm doing larger projects or more complicated things, I have a tendency to open VS Code. When I'm doing lighter things, I have a tendency to open Vim just because I enjoy Vim a little bit more. Kind of when I speak about Vim, I also have to talk about Emacs. I do believe there might be an Emacs plugin, but I'm not really sure what the state of that is. I think it may be functional, but I'm not really sure. And finally, there's always Visual Studio. Just like any other Microsoft language, F Sharp is supported in Visual Studio. So specific to F Sharp, there are some interesting testing tools that are brought to the table. So calling out specifically Expecto and FS Check. If you're familiar with Quick Check from Haskell, it's a property-based checking environment for functions. Kind of maybe the easiest way to explain it would be if you have to write your unit test, and you've had to write, well, what about this case and what about this case, or and you end up writing 10 or 15 cases to try and cover the gamut of possible things that could happen. Property-based testing allows the testing tool itself to provide some intelligence there. So if I have a function that accepts two integers, Expecto will actually randomly generate integer values the full range into that. So what that means is every time you run the test, you actually get different test values against it. It also likes to test the extremes, and it provides some really nice feedback because it helps to narrow down on what specific types of data could be causing your problem. Also, F# Make, it's another very prominent community project. It's Make, but it uses F# as a DSL. And so if you've ever had to work with Make files, you know they come with their own kind of cumbersome syntax. What's really nice about Fake is you get all the power of the F# language, but applied to your build tools. Kind of taking the ecosystem another step further is, I wanted to call out a couple specific larger projects that are F# community driven. And I think it's important because F# is a Microsoft language, and they do have a development team that works on it. But the F# community itself is really strong, and some really amazing things have come out of it. First, I wanted to mention for web development, there's a Fable project, and what it is an F# to JavaScript compilation, pairing that with Elmish, and I'm not sure if anybody's familiar with Elm, but it's effectively a functional language that allows you to do web development. And so when you pair Fable with Elmish, you can write F# applications that you can then run in web clients in a functional way. So you get a lot of those benefits. Also, there are multiple web servers to pick from. Historically, Suave has been around for a very long time, but two recent newcomers in the last couple of years have been Giraffe and Saturn. Giraffe is a lightweight F# functional and composable web server on top of the .NET Core. Saturn is actually built on top of Giraffe, but it's more opinionated, and it focuses on a larger scope. Like when you open a Giraffe template, you'll basically get a bare .NET template where you can have some routes, and that's about it. Saturn actually builds out the full kind of web client as well as web backend to the process. So depending on what kind of tools you're looking for, you get a really nice range here. Kind of feeding off of the web and web servers, there's the Safe Stack, which is it's kind of again an opinionated idea of how you can handle web development in F#. So if I get the letters right, I believe S typically stands for Saturn, A could stand for Azure or AWS, F is for Fable, and E is for Elmish. And so it's a good view of how F# developers attack the web development world. Also, you can write F# for mobile apps. Fable actually has there's a Fable and React extension that allow you to write F# applications that compile to React Native. Also, F# is supported inside Xamarin. Something I didn't put on here on the list because I wasn't really sure how well it was supported, but I've actually written F# mobile applications using F# and Cordova, because F# compiles to Fable and Cordova just runs web apps effectively inside a container. It's actually a nice lightweight way to get things going. So other big callouts are the F# compiler services. If you're familiar with Roslyn, the .NET compiler, it carries a lot of the same types of concepts from there. So as a little bit of background, Roslyn is not just a strict compiler, but it actually exposes itself as a library and an API. This allows all sorts of power that development tools can leverage. F# compiler services take that a step further, where it effectively builds on those same types of ability, and the F# compiler services actually are exposed as a library. So things like Ionide, when they're providing development capabilities inside VS Code, leverage things like FS autocomplete and the compiler services to provide some nice real-time feedback for development. Also, there's F#. There's the F# Plus library, and If you were one of the people who are interested by computation expressions because you like monads and some of the functional aspects of languages and you like to play in some of that theoretical world, F# Plus is a good library to look at. It provides you things like lenses and functors and bifunctors and kind of all that goes into that. Also, fparsec is a really neat tool. If you're familiar with the parsec library from Haskell, it's effectively an F# port. It is a parser combinator. It's a parser combinator library, and it allows you to do nice parsing of data. It provides a nice composable way to process some data. FS Reveal, it's a smaller project, but I wanted to specifically put it on the list because that's actually what the slide deck is written in. It is an F# application that will take Markdown and convert it to the reveal.js to provide a really nice kind of a really nice functional slide deck. So I just kind of wanted to put that on because it was kind of a fun tool to use. So after all this, where can you learn more? Because hopefully at this point I've piqued your interest enough that you want to find some information, some additional information. First, you can go to fsharp.org. That's the foundation-driven site. There's also a forums that the foundation drives as well. It's a good place to ask questions and kind of see what kind of communications are going on. Also, there's an F# Slack. So through the foundation, you actually have to sign up. It's free to sign up, but the Slack is where a lot of the F# community congregates, and it's a place to really get in contact with some good, knowledgeable people if you have F# questions. They are tremendously helpful and knowledgeable. Also, there's a GitHub project where they called Awesome F#, and if you want to know what kind of things so if you have an idea that you want to do something in F#, but you don't really know what library to use or what kind of tooling is available, Awesome F# provides a good way to say, in the F# ecosystem, what are some of the prominent projects that exist and how potentially can I use them? And they're broken out by web and by database or machine learning, and it tries to cover that gambit of, if I don't know where else to look, I go there and I kind of see what exists. So also there's one of the community members has an F# weekly that he publishes, and he basically keeps an eye out for F# articles and blog posts and news items. And if you don't want to scope the internet constantly for news, you can check his website out occasionally, and you get some really nice information. Also, if you want to learn F# at any point in more detail, you will inevitably come across the F# for Fun and Profit website. This is a really good website because he's gone through he's gone through all the different components and methods that you would use in F#. It's a really good educational tool, and he covers all the concepts in F# tremendously well, and he has a multitude of blog posts. Also, FS which is it's just a snippet website where F# people put little small tidbits out, and so sometimes it's nice because you can grab a little bit of code here and there. It's just maybe 10 lines or 15 lines of something, and it's just solving little problems. Also, a little bit of self-promotion. But I have a blog that's codesuji.com, and although I like to talk about different things kind of in the language world, most of probably 99% of my posts are actually F# based. So I'm biased, but I believe that's also an interesting resource to check things out. It covers some of the types of things that I'm interested in, but I also like to focus on if I have F# in the business, and what are the typical business needs that I would use it for, and I try and tackle some of that stuff, because sometimes just to get started you just need some code examples, and that's what I try to provide. So after all that, I recommend everybody go out, get started, play with F#. It's easy enough. You can go out to .net, which is a Microsoft site. You can download .net Core. You can do .net New Console, define your language, and get going. So that's actually all I had for the presentation tonight. I don't know if anybody had any questions. or or comments. I'm certainly willing to go over any of the. If I was talking too fast over something, I can certainly go back over it. I'm more than happy to do that. I also have some additional syntax that I didn't want to bore people with just reading. Like I said, I didn't want to read code for an hour. But if people have specific use case questions or just about the ecosystem or anything, I'm certainly more than happy to answer them. Let's see. So I hopefully you enjoyed this little talk about F#, and it gives you a little bit of a view into what F# brings to the table. I think that it provides an interesting way to solve problems. I think it really can be something, even if you don't use it in business, it's something to spend a couple hours with on an evening or a weekend and just play with. It helps to show what kinds of things you can do. So I'll just check here, see if there's anything coming up. Catching it late. Okay. Let's see. I don't think I see anything else right now. Where'd it go? Oh, there we go. So, certainly I think I'll stay on the line here for a little bit. I'll try and protect myself from rambling too much, but if you have any questions, and we can either I'll kind of hang out here for a couple minutes just to see if anybody has any questions, and then just so there's not completely dead air, because nobody really wants to hear that. What I can do while I'm waiting for questions is I'll go back to so I'm a pack rat, and so as I was trying to come up with this talk, I had some different some of the different syntaxes I thought might be interesting to people, but I didn't want to potentially overwhelm anybody. Functional languages also have they query their parameters. So there's a concept of partial application. So you can do that in F#. F# also supports recursion, but you explicitly have to call it out. You'll notice in line 1, I explicitly call out that the function is recursive. What's great about this is that you can't accidentally make a recursive function. You have to do it intentionally. Also, if you need to wrap tries, there are try with. You can do matching based on the type of exception that you get back. You can also do some very specific exception calling itself. Also, it's multi-paradigm. It supports multiple different kinds of classes, so it also supports interfaces. So you could define an interface. You can certainly make the class and then use that interface, but you have to explicitly call it out. It's kind of a nice way to handle that. Match patterns, like I said, they're switch statements on steroids, so you can actually write your own custom patterns to match against. So this again is kind of a silly example, but the match is a really powerful tool in F#. If you want to organize your data, you will typically use modules. So this is what a module would look like. It's pretty useful. So okay, that's actually all the syntax that I have. So I don't see any questions. So I'm going to assume that meant I was thoroughly informative, and there's nothing else to discuss. But I think at this point I'll probably will call it for the stream. But just give me a minute here.